Good morning. My name is Gurdipti. Today topic is exploring infinity state automata with Junun robots, a case of in computation theory. Introduction of infinity state automata. Infinity state automata are mathematical models that represented systems with a finite number of states and transactions between them. They are widely used in a computer science and engineering to model various real-world problems. In case of study, we can explore the concept of FCA using of Junun robots, which are programmable robots designed from educational purpose. By programs, this is robots to perform specific tasks. We can gain a better understanding how FSA works and their particular applications. Understanding computability theory. Computability theory is a branch of computer science that deals with the study of algorithms and their limits in seek to identify the types of problems that can be solved by algorithms and those that cannot. Exploring FSA with Junun robotics, we can gain in effects inside computation theory and its particular application. We can examine the limits of what can be and idea problems that are behind the scope of FSA. Programming Juno robots from FSA. To explain FSA with Juno robots, we can first need to program them to perform specific tasks. This involves designing a set of instructions that the robots will follow to achieve the designed outcome. We can then observe how the robots move through different states and transitions as they execute the program. By analyzing their patterns, we can gain a deeper understanding of FSA and their behavior. Applications of FSA is a computer science. FSA has many particular applications in computer science, including natural language processing, pattern recovering, and compiler design. By studying FSA with Juno robots, we can gain in effects into these applications and their potential import on the field. For example, we can use FSA to analyze the structure of sentence in natural language and identify pattern in a text data. We can also use FSA to design effectively compiled that we can translate high language into machine code. Limits of FSA. While FSA are useful from modeling many real-world problems, they have limits. One major limit is their inability to handle problems that requires an infinite amount of memory or computation. By studying FSA with junior robotics, we can gain a better understanding of these limits and identify problems that are behind the scope of FSA. This can be used for developing new computation models that can be handle more complex problems. Now exploring infinity state automata with Juno robotics. Through our case study in computation theory, we can well develop into the world infinity state automata and exploring their limits. By using Juno robotics to model complex problems, we can gain a better understanding of how their missions process information and make decide based on their current stage. This also has developed new computation models that can handle more computation and memory tasks. Our exploring of FSA with robotics offered a unique opportunities to observe how their missions work and identify areas where they follow short. By analysis this behavior we can gain in effect into how to import their effects and their performance leading to new breakthrough is a field of computation theory. Robotics offer a unique opportunities to explore the limits and capability of infinity state automata. By programming their robot to perform specific tasks, we can observe how they process information and make decide based on their current state. This also has again their understanding how FSA works and how they can use solve real world problems. Through our case study, this computation theory will be examining how robotics can be used to model explain problem and identify areas where FSA falls short. By analytics the behavior of their robotics, we can hold the develop new computation models that can be handle more computation and memory effect state. Conclusion. In conclusion, exploring FSA with genetic robotics in an effect many ways to gain insight in computation theory and its particular application by programming these robotics to performing specific tasks. We can gain a better understanding of how FSA works and their limits. In knowledge, we can apply to various fields including computer science, engineering and artificial intelligence. By continue to explore FSA with general robotics, we can push the boundaries of what is purpose in this field and develop new computation models that can handle increasing complex problems. Thank you.